My name is Shivani Hariprasad and today we'll be discussing about load balancing, why we need load balancing, the algorithms and strategies used by the load balancers and the types of load balancers that are available. Firstly, let's consider a website and let's say a user sends a user request to your website. The backend servers or let's say at this scenario, one backend server will respond to the user request after processing it. But this is all well and good if there is one user. But what if there are millions of users? In that case, the website will crash because the application server has some infrastructural limits up to which it can take the load. So in that case, let's say we have multiple application servers. But now how does the user know where to route his network traffic or his user request to which application server, right? In that case, that's when load balancer can come into play. It can be a hardware or a software like HA proxy type of load balancer. Now, load balancer facilitates the equal or uniform load distribution among the application servers or the backend servers, thus ensuring the entire processing is conducted in a very efficient manner. Now, one of the features of load balancers is auto scaling. What is auto scaling? Let's say there is some extra load coming in for the website at some point of time, and all the application servers are at the maximum level. Let's say they are running at 90% CPU, they are at the bottleneck. In that case, we need another application server. So it can bring up another application server. Okay, and if the load is very less and if the application servers are quite free, in that case it can bring down an application server. So this feature is called auto scaling. It also makes the entire website very resilient because if an application server comes down, it can bring up another application server, thus ensuring zero downtime. Now let's discuss about the types of load balancers. First one is the application load balancer or layer 7 load balancer. So this is content based load balancing. So it basically reads or scans the entire HTTP packet and then it makes the decision either based on the HTTP header content or the web request URL or the HTTP method used or the type of requested data or the browser cookies. Alright, that is very smart routing decisions. Now in case of a network level or the network layer load balancing, it basically forwards the TCP or the UDP packets and makes routing decisions at the transport level. So there is less overhead in it because it does not do a lot of content reading, right? Whatever is the content of those packets, except the initial source and destination address. So these two layer 7 and layer 4 that I told are from the OSI model, the layer 7 layer OSI model. Now let's talk about the algorithms and the strategies that are used by these load balancers to forward the traffic to the application or the backend servers. First one is round robin. It's a very simple way where the load is uniformly distributed among all the backend servers that are there. So let's say there are 4 user requests. First one goes to the first application server, second one goes to the second application server, third one goes to the third application server, and fourth one comes back to the first application server. Now this is not very ideal in a dynamic scenario because each request has a different processing time. Each request is different in its own way. In that case, we need something that's more it caters to the capability of the application server. So in that case, the weighted round robin is a better choice. What it does is it takes into consideration the configurations of any application server and it routes the traffic based on that data. So whichever is more highly configured, whichever is more resilient, that's what gets the load. Next one is least connection. Basically, the traffic is sent to the application server that has the least number of active connections at a point of time. So this ensures that the load is uniformly divided among all the application servers. Next is least response time strategy. What happens is response time is the time taken by the application server to process the request and send back the requested data. So the load balancer routes the traffic to the application server that has the least response time. Thus, it makes the entire website run in a more optimized fashion. The last one is source IP hash. So the client's IP address is taken and using any hashing algorithm, we hash the IP address. Now, this is useful when the user request is in such a way that it's better a specific type of application server handles it. So it's better to keep that connection active. So for that, what we do is we hash the IP address and ensure based on that data, we route that traffic to that specific application server. This ensures session stickiness and all the load is directed to that specific application server. All in all, today we discussed about what is a load balancer, what are the algorithms and strategies used by the load balancer, and what are the types of load balancers. Thank you. Have a nice day.